So we're going to start with number 10. About the hobbyists of building compressed air powered cannon to launch pumpkin. Did they do any pumpkin trunking around here at all? No? I'm going to a Boy Scout competition of it this weekend. It's been kind of cool. When one of our local troops built a trebuchet. Today the launch pumpkin horizontal distance. This, assuming no air resistance, launch ground level is the minimum initial speed of the pumpkin. You need to reach this distance. So, when they say minimal speed, I start thinking, okay, if it's a minimal speed, that means it's at its maximum distance or its maximum range. And to be at a maximum range, and by range I mean horizontal distance a projectile travels, that maximum comes at 45 degrees. There's a symmetry around 0, 90, and 45. You know, if we fire it at 0, it goes straight up. If we fire at 90, it doesn't go anywhere because it's straight into the right ground level. It doesn't have any time to go anywhere. 45 splits those, and that gives us a maximum range. If we do any symmetrical angles around 45, like 50 and 40, they go to the exact same spot. So 45 is our maximum here. So that may be one of the things I mentioned in my why, that to minimize velocity, you maximize range. I know that's a new term, range. You could also think of that as horizontal distance, or horizontal displacement would probably even be better than distance. Horizontal displacement, let's call it. And this happens at 45 degrees, 45-degree launch angle. So that's kind of the first major fact to realize about this, because otherwise you've got no idea what direction they're firing this in. And then, of course, beyond that, let's see, the pumpkin is a projectile, therefore vertical accel equals little g down, and horizontal accel is 0. And then probably the last fact would be lands at same height it is fired. So it's important to realize that we're going to land at that exact same height as we're fired, that ground height. I'm going to draw, let's see, I'm going to draw a little picture of it. So we have our ground here. That's flat ground. Let's try that again. We have our ground here, and we fire the pumpkin, it goes up, and it comes down. Just for visual, if you remember, I think we shot it horizontally. Remember that that's just moving out at a constant rate, right? Because we have no horizontal acceleration, so you just get this constant rate. But vertically, we're moving up really fast, and then we start slowing down and slowing down and slowing down until we stop, and then we turn around and we come back down at that same acceleration, right? We separated out the motions, which is what our goal is. Our first step, though, is we need to separate before we can get down here into our separated into horizontal and vertical. We got to make sure that everything we have is separated into horizontal and vertical. And the thing that isn't is the condition right here at the beginning, which is our initial velocity. Our initial velocity in this case isn't both horizontal and vertical. It's like this, V, and it's at this 45 degrees. So we need to separate that into its horizontal and vertical parts before we can go any further. And so horizontally, it would have a component like that. Vertically, it would have a component like that. And now we have our nice right triangle. So this side would be V sine 45 degrees. This side would be V cosine 45 degrees. And now we have it separated. Now we can start breaking out into our two sides. So the velocity horizontally is our V cosine 45 degrees. And I might call this Vx just to make sure that I don't confuse it with the V that is my initial velocity, just term-wise. I know my acceleration here is 0. I'm going to call this point where it starts 0 meters and 0 meters. I know this spot here is 0 meters, but then what did they tell me? 1,600 feet. I wonder whose feet they use, what they use. So I need to right away, I don't like working in feet, so I need to convert it. Are you guys okay converting feet to meters? I just use my TI. I just go to Side Tools under Apps, and I just use that. You can, of course, multiply by the conversion factor, but I would just use either your calculator or one of, probably 200 apps online. So I'm just going to get that out of that nasty feet. Meters. I get 1,600 feet equals 487.68 meters. Which makes sense. That's like kind of like divided by 3. You go to Apps, Side Tools, and then the second choice down inside. There, you're at Side Tools yet? So I'm just going to write some things up here. Tell me when you're at Side Tools. And then the second choice down there is Unit Converter. Right? And then choose Length. From length, put in your number, like I put in 1,600. Arrow till it says feet, hit enter, then arrow till you have meters, and hit enter, and it will do the conversion for you. On the vertical side, my V initial is V sine 45 degrees. My acceleration is downwards. I'm going to call down negative 9.80 meters per second squared. Now, we know it lands at the same height. So what do we know about the vertical velocity that it begins with compared to the vertical velocity it ends with? Any thoughts? Any relationship between the vertical velocity it begins with and the vertical velocity it ends with? Huh? No? Well, because of the symmetry, because it goes up, and it goes from this V sine 45 degrees, starts up at that, goes up until it stops vertically, and then comes down, and since it goes up the same amount as it comes down, and it's influenced the same way by gravity on the way up as it is on the way down, just in opposite directions, it causes that final velocity to be the opposite of it. So rather than V sine 45, negative V sine 45 degrees. Now, if you didn't realize that symmetry or it didn't land at the same level, that's fine. You can do it without it. Just going to make calculations slightly easier if you do realize that symmetry in this problem. Let's see, what do I know? I know my D naught, 0 meters, and my D is 0 meters also. So, and I don't know my time. So, as soon as I see that I don't know my time, I start thinking, ooh, can I solve one side for time and then get any information I need on the other side? Because what I'm looking for is V, and I have that on both sides. All right, so there's not one side, and I look and I think about my path, and both the horizontal and the vertical are restrictive. No, I have to land at the same height vertically, so I have a start and an end point vertically. I have a beginning and an end point horizontally. So one side doesn't, horizontal or vertical doesn't scream at me, do me first because I'm going to determine the time. So, anybody have a preference? We start horizontal or vertical and see where we end up? Pick one. Come on, don't make me pick. Vertical. Okay, we'll start on the vertical side. So on the vertical side, looking at it, and I know the velocity it starts at, I know the velocity it ends up at, I know it's accelerating, and then I remember from my equation sheet that I have an equation that says V final equals V initial plus AT. And I say, oh, I got lots of that stuff. Now, would you guys be more comfortable rearranging this for a T now, or putting in the values and then rearranging it? So we can do it either way. We've been doing it the other way, but we could rearrange it first. No preference? We'll say how we're doing it. So I have negative V sine 45 degrees equals V sine 45 degrees plus negative 9.80 meters per second squared times T. Rearrange that. Oh, wait a minute, I have a V and a T. Since I want to find V in the end, my gut is telling me I should rearrange that for T. But let's see if I can get any further on the horizontal side. Maybe that can help me over there. Over here, I know the velocity doesn't change, so my equations that have to do with velocity changing, my V final equals V initial T, my V final squared equals V initial squared plus 2AD, aren't going to be of much help if the velocity doesn't change. So I'm really stuck by using this, my main kinematics equation. I have no other choice because my velocity doesn't change. But I know, oh, my D naught, that's 0, so I don't even have to deal with that. My acceleration is 0, which makes this whole last term 0. Because 0 times a half is 0, 0 times t squared is 0. And I'm left with my 487.68 meters equals my V cosine 45 degrees multiplied by t. But I can't go any further again because I have both velocity and time in that equation. I don't know either one. But now I've got two equations that both have the same two variables. And what math tells me, I checked with the math teachers, that if you have two variables in two equations and they're the same two variables, it's possible to solve them because same amount of unknowns as equations. You know, if we had 20 unknowns and we had 20 equations, possibility is we'd be able to solve it. So I need to solve one of these and put it into the other one. And I want to end up finding V, so I think I'd be better off solving one of these for the variable t and then putting it into the other one. That way I get rid of the t variable and I leave the v variable in there. That helps me solve for v. I think I'll solve, because I have the green pen in my hand, my horizontal for t And I do that by dividing both sides by v cosine 45. So I end up with 487.68 meters over v cosine 45 degrees equals t. And now that is my time, so it can jump my barrier, and I can substitute that in over on this other side for t. So that's what I'm going to do now. Let's see. Minus v sine 45 degrees equals v sine 45 degrees plus negative 9.80 second squared. Multiply all that multiplied by 487.68 meters over v cosine 45 degrees. And I can do some, now if I'm going to solve this algebraically for v, I need to get all the v's on one side and get all the numbers on the other side. And so I could do that algebraically because I only have one variable. What I would do at this point is either put it in Wolfram and solve, or I'd use my calculator to solve it. Which way do you guys prefer doing it? Wolfram? Okay. So I'm just going to jump to my keyboard. So I'm going to put it just as it is into Wolfram. So I'm going to go to the main site here and go into Wolfram. What I need, let's see, v sine 45. I'm going to put v times sine 45. That equals, oh, sorry, that's negative v. I better be careful. Equals v times sine 45 plus negative 9.8 multiplied by 487.68 divided by parentheses v cosine 45. Type all that in. I do a little check here that it looks correct. You know, everything multiplied out correctly, and that seems to do it. Let's see, 10 degrees. That was what? I'm going to try X rather than B, see if it's the V that's denominator. Oh, I need one more here. I think you have, I have what? Sorry. Oh, thank you. That was supposed to be a plus. That is what did it. I must have missed my shift key. $69, so thanks it all out. 69.13 to 69.1. Let's see if I got it right. we're going to do number 4 here. It says ball thrown horizontally off the roof of a building 51 meters tall and lands 45 meters from the base. What is the ball's initial speed? So, starting with our y here, the ball is a projectile. You guys see a pattern here in the y's? Well, hopefully you do. Therefore, the vertical acceleration is little g downwards, and horizontal acceleration is 0. The initial velocity is just horizontal, and ball lands below its start point. So the initial velocity is just horizontal, and the ball lands below its start point. Looking at the problem, I can't tell personally which one is more restrictive. Is it that it's going to be restricted by the, oh, wow, let's see. We know that it starts at 0 vertical. So let's look at the vertical real quick. It starts at 0 meters per second, right? Its initial velocity is 0. And we know that it's accelerating vertically, and we know that it has to land 51 meters below. Horizontally, we don't know what velocity it starts with. We know it has to land 45 meters away, but I'm trying to, and so we know where it starts, we know where it ends, but we don't know what speed it's using or what velocity it's using to get there. So if I start thinking about which one is more restrictive time-wise, is it the vertical, where I know it starts at 0, it accelerates and it lands 51 meters later, or is it the horizontal, where I don't know what speed it's moving, but I know it moves 45 meters? To me, the one that's more restrictive is the vertical, all right? Because I have more information, and I think, okay, if it was going 2 meters a second, it would take a really long time to get out 45 meters, but if it was going like 90 meters a second, it would take a really short time. Where vertically, it's going to take the same amount of time no matter what. Think back to the cannon. No matter what velocity horizontally we fired it at, it landed in that 3.19 seconds. So I'm going to note that the vertical dimension is controlling the time. And if you don't see that, that's fine. You can get there by trial and error, by knowing, trying one dimension and running into a kind of a roadblock, and then going back and using the other side, like we did in the last problem. But if you can see that, it's going to save you some blind alleys. So here we have our building. We shoot this out, it goes down like that. They tell me that this is 51 meters, and this is 45 meters. Let's call up positive and to the right positive. That would make, I'm going to say at this point here that it launches at is 0 meters and 0 meters. So that means this point down here that it lands at, vertically, it would be at 45 meters horizontally, but vertically it'd be at negative 51 meters by putting 0, 0 up there. All right? Yes? No? Yes. Yes, no? Copy. That's fire. Alright. So, horizontally, its velocity is unknown, its acceleration is 0, its starting point is 0 meters, its ending point is 45 meters. Vertically, its initial velocity is 0 meters per second, its acceleration is negative 9.80 meters per second squared, its final velocity, no clue. Its starting position is 0 meters. Its ending position is negative 51 meters. And as I said, I think the vertical is more time dependent, so I'm going to use that side. I don't know the final velocity. I really don't care what it is because I'm looking to get time to kind of break the gap. Whenever I don't know time, it's usually a good idea to try to find it, usually. Especially since I'm trying to find something on the horizontal side, and that's the only thing that links them. So I'm going to start over here, and I'm going to start with d equals d naught plus v initial t plus 1/2 a t squared. It ends up at negative 51 meters. It started at 0 meters. Its initial velocity, its initial velocity is 0. This is 0. I get rid of both of those. I'm left with 1/2 negative 9.80 meters per second squared t squared. I'm going to solve for t. Grab my calculator real quick. I end up with a t of 10.4081637 seconds. That is, I'm going to bring over to this other side so that I can now solve this side. Again, since I'm not accelerating, I don't have many choices over here. Equals d naught plus v initial t plus 1/2 a t squared. I end up at 45 meters. My d naught is 0, so I don't even have to consider that. My acceleration is 0, I don't have to consider that. Equals my v, which I don't know, and my time, 10.4081637 seconds. Solve for v. And I get 4.32 meters per second. Let's see if I got it. Let's see, 4.32. Let's see, what did I do wrong? Any money numbers? Oh, you know what I forgot? I forgot the square root. So I forgot this should be 10. I forgot to take the square root. That 10 is t squared. I forgot. I did the most common mistake. That comes over here. And I get 13.9